Hello, my name is Galat Nerita and I am an associate professor in Kaunas University of Technology. In this video, I will talk how fuzzy logic can be applied in complex systems. Nowadays, application of artificial intelligence is usually based on the analysis of historical data. However, if there is not enough data to train a model or computational resources are limited, expert systems can be employed to solve problems that are difficult enough to require significant human expertise for the solution. Such systems consist of a knowledge base, inference mechanism, and user interface. The knowledge base consists of data, information, experience in a form of if, then, else rules. It's created by the expert and the knowledge engineers who summarize the expert's knowledge. The inference mechanism enables to apply inference rules, use constraints, and adapt examples. The user interface mechanism provides interaction between the end user, who's not necessarily an expert, and the expert system. Expert systems are applied in medical diagnosis, investment analysis, fault detection, and many other fields. They combine knowledge of many experts, work faster than humans, can deal with large amount of information, and are accessible 24/7. The most important part in expert systems is to convert experts' knowledge to a form that computer can understand. And fuzzy logic is used in this step. Usually the experts define cases and rules in a textual form. Here you can see several examples such as if the weather is cold, then, if pollution is high, then, if service is good, and so on. However, it's not clear what weather is defined as cold or what service is described as good. Moreover, these terms are subjective and depend on the expert's experience. For example, for some people, a temperature of +5 degrees of Celsius means cold weather. Others define weather as cold only if the temperature is lower than -5 degrees of Celsius. Moreover, in the conventional Boolean logic, the value can belong to only one category, whereas in the fuzzy logic, there can be several answers with the level of dependency defined by the value of membership function in range from 0 to 1. Various membership functions can be applied in the fuzzy logic models, for example, triangular, Gaussian, pie-shape, and others. The decision on which membership function should be used belongs to the knowledge engineer, who understands the relationship between numerical and textual values best. As in the conventional Boolean logic, there are three main operations, that is intersection, union, and negation. Although in this example we present intersection as minimum of two functions and union as maximum of two functions, there are other ways to define them. The results of these operations are shown in red. Fuzzy logic is a superset of the Boolean logic because if fuzzy values are at their extremes of 0 or 1, standard operations will hold their values in the truth table. Let's analyze an example how fuzzy logic can be applied in practice. The objective is to estimate the risk level of a software engineering project. The fuzzy sets of output are provided in the figure on the right. The ratios of project funding and project staffing are known. That is, project funding is 26% and project staffing is 56%. The expert rules to define the risk level of a project as follows. If the project funding is adequate or project staffing is small, then the risk is low. If project funding is marginal and project staffing is large, then risk is normal. If project funding is inadequate, then risk is high. The fuzzy sets of project funding and the project staffing are given in the pictures. The next step of analysis is the fuzzification procedure. In this step, the dependency levels of each membership function are calculated for the known values. In the rule application step, the fuzzy logic operations are applied to evaluate the level of risk. And then, each membership function is filled up to a certain level obtained after applying the operations. The final step is diffusification. Again, there are several methods which can be applied to estimate the risk. Center of gravity, bisect, or smallest value of minimum, just to mention a few. In the current example, we use the method that is called a mean of maximum. The mean of risk levels that have the largest membership function value is 86%. Obviously, different methods give different estimations. Thus, the risk value is estimated for different projects can be compared only if the same methods and membership functions are used in the estimation procedure. To sum up, fuzzy logic enables to convert textual rules formulated by the experts to a form that computer can understand. This helps to share knowledge and solve problems that require human expertise using computers. For more information on teaching complex systems and systems thinking, please visit the project website.